Okay, let f at x equal that. So we have to find the derivative. So that's 3x squared minus 4. And the tangent to the curve of f at the point 1, negative 2 is parallel to the tangent at a point q. Find the coordinates of q. So we need to find the derivative at 1 because that will give us the gradient. So that's going to be 3, so negative 1. And then if we set that equal to negative 1, we can find the other x coordinate where it's negative 1. So 3x squared equals 3, x equals plus or minus 1. So x equals 1 is going to be the x coordinate of q. And if we sub that back in to the original function, we're going to have 1 minus 4 plus 1. So negative 2. So that's the point Q. Okay, so then we've got the graph of f is decreasing from P to Q. Find the values of P and Q. Okay, so B, we need the derivative to be less than 0. And remember, this is a quadratic inequality. You can't just go solving this like a normal inequality. You need to find the zeros. So that's going to be, so set it equal to 0. So x squared equals 4 over 3. And then we have plus or minus square root of 4 is 2 over root 3. Okay, so we have negative 2 over root 3. We have 2 over root 3. And then we can check 0. And we can check 2 and negative 2 because 2 over root 3 is 1.15-ish. Okay, so now we sub that into the first derivative. And that's going to be, so that's 3/12. So this is a positive. 0 is going to be a negative, and 2 will be positive. So it's decreasing from, so P is going to be negative 2 over root 3, or whatever form they want that in, and Q is 2 over root 3. Write down the range of values for the gradient of f. Okay, so this gradient is 3x squared minus 4. That is a quadratic looking like that. So it's going to be greater than negative 4. Or equal to, yeah. Okay, so then we have, find the coordinates of the point of inflection. So we need second derivative here. First derivative's here, so we're going to have 6x. Set that equals 0. X is 0. So they tell us the point of inflection. We just need to sub back into the original function, which is going to be 1. So 0, 1 is the point of inflection. All right, 46, we've got this. The graph of f is given below. The y-intercept is at A. Find the coordinates of A. Okay, so for that one, we just sub in x is 0. So that's going to be 3 plus 20 over negative 4, which is negative 2. And it looks like it. Double I, show that the derivative equal to 0. Show that the derivative is 0 at A. So first derivative, 3 goes away. So this is 3 plus 20 x squared minus 4 to the negative 1. So the derivative is going to be negative 20 x squared minus 4 to the negative 2, times 2x. So negative 40x over x squared minus 4 squared. And if we set that equal to 0, denominator goes away, negative 40x equals 0. X is 0. Okay? So that means at 0, the derivative is 0. So at x equals 0, the derivative is 0. All right, B, the second derivative is that. Use this to justify. Okay, so we need the second derivative at 0, which is 40 times 4 over negative 4 cubed, which is 160 over negative, it doesn't matter, it's a negative number, 64. But this is less than 0, which means it's concave down. So that means there's a max at x equals 0. Explain why the graph doesn't have a point of inflection. So second derivative equal to 0. So it's just the numerator equal to 0. The denominator gets cross multiplied. Divide by 40. And then we'll have 0 equals 3x squared plus 4. Minus 4 over 3, well, it's squared, so it's never equaling a negative number, okay? So it doesn't have a point of inflection. Describe the behavior of the graph of f for large absolute values of x. Well, it's going to go to the horizontal asymptote 3. So, because it's getting closer and closer to that horizontal asymptote. Y equals 3, so that's C. Write down the range of f. So we are going to have y greater than 3 for that top part, or y less than or equal to negative 2, because that's the max there. All right, 47, we need to show the first derivative. Okay, we've got first times the derivative of the second plus the derivative of the first times the second, and we can factor out e to the x, and that's going to be negative 2x plus 1 minus x squared, which is what they have there. All right, part of the graph of f at x is shown from negative 6 to 2. The x-coordinates of the local min and max are r and s. Write down the equation of the horizontal asymptote. Well, it's at x equals 0. No, y equals 0. So then, write down the value of r and s. So we need to set the first derivative, equal to 0. Well, e to the x is never 0, so we just have, let's switch the signs around. We just have this. So not factorable, we need to use quadratic formula. Negative b plus or minus square root b squared minus 4a is 1, c is negative 1, all over 2 times a, 1. So negative 2 plus or minus 4 plus 4, so root 8. And then that's going to be 2 root 2 when the 4 comes out. So we're going to have r is going to be negative 2 minus 2 root 2 over 2, which is actually, I should have canceled it, negative 1 minus root 2. And then s is going to be negative 2 plus 2 root 2 over 2, which is negative 1 plus root 2. And then show that the normal L to the curve f at p 0, 1 has equation x plus y equals 1. Okay, so we need to find the first derivative at 0. And they give us the x and y. So the first derivative at 0, using that, we've got e to the 0, then 0 plus 1 minus 0. So it's just going to be 1. Okay, so we're going to have y, so the point is 0, 1. Okay, that's it. So y equals m is 1. No, because we want the normal. So the normal is negative 1. So negative 1x, y-intercept is 1. So add the x over. We show that. Find the coordinates of the points where the curve and the line L intersect. So we want negative x plus 1, the normal, L, equal to e to the x 1 minus x squared, and that's done on the graphing calculator. So you end up getting the point 0, 1 and 1, 0. All right, number 48, we've got this function, and part of the graph is shown. There's a max at A and a min at B. Find the coordinates of A. So we need to find the first derivative, which is going to be 3 times the third, which is 1x squared minus 2x minus 3. And then we have to set that equal to 0 and factor. So x equals 3, which is the b coordinate, and x equals negative 1. So if we sub in negative 1 to the f function, we've got 1/3 times negative 1 cubed, which is negative 1, minus negative 1 squared is 1, and then minus 3 times negative 1 is plus 3. So negative 1/3 plus 2, so we have 1 and 2/3, or 5/3. Okay, so that is going to be A. Write down the coordinates of the image of B after reflection in the y-axis. So that means it's going to flip over the y-axis. It's going to be -3, -9. The image of B after translation by the vector -2, 5. So it goes -2 in the x direction and 5 in the y. Okay, so you're just subtracting 2 from x's and adding 5 to the y's. The image of B after reflection in the x-axis. So here it's going to still have the same x, but a +9, followed by a horizontal stretch with scale factor 1/2. So you're just multiplying the x by 1/2. So 3/2, 9 should be the final answer. All right, we have to use quotient rule here to find the derivative. So we're going to have sine squareds on the bottom, so v squared, and then we have sine times the derivative of cosine, which is negative sine, and then minus u times the derivative of v. All right, so we're going to have negative sine squared x minus cosine squared x over sine squared x. So if we take a negative out, that's sine squared plus cosine squared, which is 1. So that is A. If we want to find the second derivative, you can treat this as negative sine x to the -2 and then just do power chain rule. So you're going to have 2 sine x to the -3 times cosine x. So that's going to be 2 cosine x over sine cubed x. So in the following table, we've got the first derivative at pi over 2 is p, and I think this means the second derivative at pi over 2 is q. The table also gives approximate values of both of those near x equals pi over 2. Find p and q. So if we want the first derivative at pi over 2, we've just got -1 over sine pi over 2 squared. Sine pi over 2 squared is 1 squared, which is 1. So this is -1. And the second derivative at pi over 2 is 2 cosine pi over 2, which is just going to be 0. 0 over 1, so 0. So Q, P. Use the information in the table to explain why there's a point of inflection on the graph, because it changes sign from positive to negative here. And also at pi over 2, the second derivative is 0. So that's the first kind of requirement it's got to have. All right, 50. The diagram shows this graph from -2 to 3. The graph has a maximum point at AB and a point of inflection at D. Find dy dx. Okay, so you have first times the derivative of the second plus the derivative of the first times the second. And then that's that. Find the exact value of A and B. So we can pull out e to the x. And this is what's inside the bracket. So those will cancel. So if e to the x times 2 cosine x. And if we set that equal to 0, e to the x isn't 0 ever. So we have cosine x is 0. And that's happening at pi over 2, which is going to be that one. Pi over 2 is about 1.57. So, yep, that's A. B's, when we sub that back in to the y, so e to the pi over 2 cosine pi over 2 plus sine pi over 2. And that's going to be e to the pi over 2, and then cosine pi over 2 is 0, sine is 1, so e to the pi over 2. So C is going to be the point, pi over 2 e to the pi over 2. So then, show that at D, y equals that. Okay, so we need second derivative. So of this, that's first derivative. So we have first times the derivative of the second plus the derivative of the first times the second. So we can pull out a 2e to the x, and that's going to be negative sine x plus cosine x. And then we set that equal to 0 to find the inflection points. E is never, so we have negative sine x plus cosine x is 0. And then we have cosine x is sine x, and then 1 is sine x over cosine x, which is tangent x. And that is happening at pi over 4. Because sine and cosine are the same. And then we need to sub that back in to, so we have e to the pi over 4 cosine pi over 4 plus sine pi over 4. So plus. So that's e to the pi over 4. And this is root 2 over 2 plus root 2 over 2, which is 2 root 2's over 2 times e to the pi over 4. So we've got root 2 e to the pi over 4. Check. Okay. 51. Part of the graph of that is shown. Write down the equation of the horizontal asymptote. So 1 plus, no. Horizontal asymptote. Because the denominator is also never 0. Anyways, it's the smaller degree, x0 over x squared, so it's going to be y equals 0. Find the derivative, so we can write f at x as 1 plus x squared to the negative 1. So the derivative is negative 1 plus x squared to the negative 2 times 2x. So this is going to be negative 2x over 1 plus x squared squared. And then second derivative is going to be, so we've got 1 plus x squared squared, which is to the 4th. Starting with v times the derivative of u minus u times the derivative of v. Subtract 1 times 2x by chain rule. And then we're going to have negative 2, 1 plus x squared squared. And then this is going to be plus, and we've got 2, 4, 8x squared. 1 plus x squared, and then all over 1 plus x squared to the 4th. And now we can pull out a negative 2, 1 plus x squared. And then on the inside, we're going to have just 1 plus x squared, because we need another one of those, minus 4x squared. That's fine. And then 1 plus x squared to the 4th. This and this. We're going to have a negative 2 on the outside. And then on the inside, 1 minus 3x squared. When you get those together, over 1 plus x squared to the 3rd. So that's going to be 6x squared minus 2 over 1 plus x squared to the 3rd. And that's what they wanted. Let A be the point on the curve where the gradient of the tangent, is a maximum. This is at an inflection point. That's where it's the steepest. So find the x-coordinate of A. Okay, so we want to set our second derivative equal to 0, cross multiply. So then we're going to have 6x squared minus 2. So x squared is 2 over 6, 1/3. So x is plus or minus root 1 over root 3. So those, I think both of those are the answer. Oh, yeah, it's only the negative one because this is a positive gradient there. This is a negative, so the maximum is here. So that is at negative. So A is, the x-coordinate is negative 1 over root 3.